Okay, hello everyone. We'll be talking about page replacement algorithm today. After the completion of a presentation, you will be able to apply FIFO algorithm to the given input string, calculate percentage of page fault and percentage of page hit. The first in first out page replacement algorithm is one of a kind of a demand paging algorithm which find out a victim page based on its arrival time. Earlier the arrival time, the more chances that the corresponding page will be declared as an victim page. The victim page will be taken out from the corresponding page frame and will be replaced by a newly arrived page. If you could consider a particular page which has been existing in a page frame, let's say that duration will be considered as an age, then the most aged, or you can say the more will be the age, the more likely that corresponding page will be declared as a victim page. Let's take an example. Now in this case we have taken some input reference strings which has been shown over here. We'll be considering number of page frame as 3 and we'll be finding out whether it generates a page hit or page fault. Hits will be generated wherever there is a page which has been asked has been present inside a page frame only, otherwise it will be considered as a fault. Now let's consider the first instance. Let's say 0 has been asked. Now 0 does not present inside the main memory, so we generate it as a fault and will be placed in a page frame number 1. Likewise, as the 2 comes, we'll be retaining 0 and placing the page 2 in the subsequent field. Again it is called as a fault. Same way with the 5. As long as we have the space in a page frame, we're gonna keep on accommodating new pages which has been arrived. Otherwise we have to find out a victim page, for which we're gonna use the today's algorithm, that is FIFO, or first in first out. Now let's consider the next instance where the 6 has been arrived. Now we do not have the empty space inside a page frame, so what we have done is we have to find out the victim page. Now in this case the most aged, or you can see the page which has been residing for the longest in a page frame, is 0, so 0 will be replaced by 6 and 2 and 5 will be continued as it is. Then next is 4. Again you'll find out that in a new set of page frame, the page 2 has been residing for the longest, so it has to be replaced. Then next is 5. As the 5 comes, we'll get a hit, as because the page which has been asked is present inside the main memory or a page frame. Then again a 2 comes. Now the most aged page present inside the page frame is 5, so it has been replaced by 2 and it is a fault. Likewise, when the 1 has been asked, 6 has been replaced by 1, rest all have been retained and it is a fault. This continues, 4 replaced by 3. Then at the last we get a 2 which has been asked is present inside a main memory, so we get the hit. Now to calculate the percentage of page fault, it can be obtained by the number of page fault by the total number of pages multiplied by 100. Now in this case we had 8 number of page fault and the total number of pages asked are 10, so we get the 80% as a result. Likewise for the page hit, we'll be getting the 20%. Now please solve the given example. Now consider again the same constraint, only the sequence of page or the reference string has been changed, the number of page frames are kept as 3, reply back or submit your assignment into the Google Classroom for this. Thank you.